Alright, so now we're going to look at identifying attributes of a function by looking at the graph. So for instance, on the graph shown, we can see that the function's domain is x from 0 to 11. So again, domain is all of the possible x values we have. So looking left to right, smallest x value is 0. Our function continues until we get to 11, and that's when it stops. Then the range is from -1 to +1. Again, looking from the bottom to the top, our smallest y value we hit there is at -1, and our largest y value we hit is +1, so that's our range. So the main things we want to look at are what's happening over certain intervals. So starts out by talking about positive and negative. So if we look from the interval of 1 to 3, so that means we're looking at just this section here. Are these values positive or negative? Well, they're positive because they're above the x-axis. So on that interval, we're just looking at this window in time, those x values between 1 and 3, our function is positive because it's above, those values are all above the x-axis. Whereas if we look on the interval from 8 to 9, from here, again, we're just looking at the snapshot in time, those values are negative because they're below the x-axis. So positive values exist above the x-axis, negative values exist below the x-axis. Now, we also want to think about increasing and decreasing. So increasing, it means it has a positive slope. So if the function is increasing on an interval, it has a positive slope. Whereas if it's decreasing on an interval, it has a negative slope. Negative slope. So if we're looking on the interval of x values between 2 and 4, it's from here to here. We notice it's going down. It's got a downward slope, so that means it's decreasing. Whereas if we look from 4 to 6, that's here. Now we've got an upward slope, so it's increasing, positive slope. We also talk about rate of change. Remember, rate of change is just a fancy way to say slope. Rate of change is just another way to say slope. So if we're looking at the rate of change from 0 to 2, that means we're looking what's happening at 0, what's happening at 2. So remember the slope formula. y2 minus y1 over x2 minus x1. Change in y over change in x. So we look at our y value at 2, that's 1, minus our y value at 0, which is -1, over our x value at 2, minus our x value at 0. So it gets us 2 over 2, which means it has a slope, or a rate of change, of just 1. So we also talk about turning points. Turning points are where we go from either positive slope to switch to negative slope, or negative slope switching to positive slope, and those happen at the maximum and minimum values. So like up here would be a maximum. It's changing from positive slope, it's going up, now it switches to going negative. That means this is a maximum. So if we want to notice how many points does the function change from increasing to decreasing. So here it's increasing, now it's decreasing, that's 1 spot. Increasing, decreasing, 2 spots. Increasing to decreasing, 3 spots. And then what's the function's value at those points? So the value of the function, that's the y value, those have a value of 1. So how many points does the function change from decreasing to increasing? So you can see here we're decreasing, now we switch to increasing, so that's 1. Decreasing to increasing, that's 2. What's the value at those points? Again, that's the y value here, that's at -1. And then a 0 of a function is basically where it crosses the x-axis. Crosses or hits the x-axis. So how many does it have? 1, 2, 3, 4, 5, 6. And then what are those values? 1, 3, 5, 7, 9, and 11. So we can use these to do some modeling. Basically, you're just going to interpret some of their words here to see whether stuff is increasing or decreasing, stuff like that. You should be able to figure this out on your own. We can work through one together here at the end. So a grocery store stocks shelves with 100 cartons of strawberries before the store opens. So our x-axis here, we notice is time since opening. So before the store opens, that would be at time 0. So time 0, we should have a coordinate here at 100. For the first 3 hours the store is open, the store sells 20 cartons per hour. Okay, so if we start at 100, we sell 20 cartons per hour. So at hour 1, we'll be down 20 cartons to 80. Hour 2 will be down 20 cartons to 60. Hour 3 will be down 20 cartons to 40. The store then restocks 10 cartons each hour for the next 2 hours. So 1 hour we'll add 10, next hour we'll add another 10. In the final hour the store is open, 30 cartons are sold. So if we were at 60, we'll drop down to 30, and that is our function. And I believe, linear regression. Linear regression. So this is probably something you should make sure to practice. So I would work through a couple of examples, both here and maybe some of your homework ones. Now, before you take your quiz and your tests, your calculators do get cleared, their memory gets cleared. So these things do have to be turned back on once your memory gets cleared in order to get all of the information that you need. So I'll make sure to remind you on quiz and test day, but you do need to make sure you turn diagnostics on again and turn stat plot on as well. But the main thing you do is you're going to plug in your coordinates. So you hit stats, and then you'll hit enter, then you'll plug in your points. If you want to graph it, you can graph it. If not, you can just go back to the stat button, slide over to calc, and then hit number 4. That should get you that linear regression equation, or it should say it should give you the A and the B values so that you can create that equation yourself. So again, I would suggest maybe checking these out on your calculator, making sure you know how to do them, specifically how to plug in your coordinates into those columns, and then how to get this linear regression equation, because that's what's going to be really, really important for you to know how to do before your quiz and test.